Want to make your laundry smarter instead of it just sitting there in the washing machine all day and never getting dried? Let's do some power monitoring with the S31 Sonoff and some voice notifications.
Listen up, that's right. You, go move the laundry over to the dryer.
And if you have a gas dryer, we're going to make it smarter too.
Hey, guess what? The dryer is done. Exciting stuff, right? Let's get started.
So to make the laundry smarter, we're going to use the Sonoff S31. It has energy monitoring out the box using the iwi Link app. But of course, you know that's not fun on this channel. We're going to flash it with Tasmota. And we're going to show you how. This Wi-Fi plug is probably one of my favorites of Sonoff. It's really simple, very minimal. Standard US plug on the front. There's two LEDs and there's one button on the side. It does support 16 amps. And take note, to do your dryer, you will need to have a gas dryer. If you have, in the US, if you have the 240 two-phase dryer, this won't work for you because you won't have this standard plug. So what's cool about this switch, I like that it does fit where you can actually put two of them on top of each other if you wanted to. One of the problems I find with these Wi-Fi plugs is they're so big that they'll cover the other plug. If you plug one in here, then it may stick up and cover the other one, or it just sticks up just enough just to irritate you where you can't plug something into the other plug, no matter which way you turn it. These, you can actually plug two of them on top of each other if you like. So to open this thing up, it's really simple. It's like IT meant for us to open this up and put it back together. Some of the problems you'll have with various other plugs out there in the field is they'll glue them together and you can't take them apart and put them back together without having to destroy them. And of course, what good is that once you destroyed the plug? So we're going to use my trusty Swiss Army knife, which I should probably use a prying tool, but so I don't cut myself one day. But it's really simple. A blade or a prying tool right here in the back, and you simply pop the gray piece off like so. And you see there's just 4 clips, and it pops on and pops off, and that pushes that button right in here, which does happen to be GPIO 0. We won't have to solder something additional for GPIO 0. We'll do like the Sonoff basics. When you flash it, you hold down the button. You'll notice these pieces right here, these curved pieces. You can either take your blade and stick it in there, or just a fingernail, and you slide these pieces out. They slide off really easy. And we'll slide the other one out like so. And you'll see there's 3 screws that will take it apart. So we'll take the 3 screws and we'll jump ahead. Once you have your 3 screws out, if you just hold the case in your hand, grab the plugs, pinch them, and slowly pull, the case comes off and reveals everything inside. And one other feature I do like about the S31 is the fuse right here. It comes with the fuse to prevent any overloads or whatnot of you overloading the relay in the device. I've already flashed this one in the past, but I wanted to show you guys again how to flash this. So yours won't have this little bit of solder on here, but we're going to pull that little bit of solder off and solder new leads to it. And don't be afraid when we say soldering. For example, I had a friend of mine that he had never soldered in his life, and we got him a soldering station and some very fine solder, which I'll link the soldering station and the very fine solder and the jumper wires, and I walked him through, much like I'll do on this video, except I didn't give him video. He walked all through verbally, and he was able to solder all to the pads himself and flash an S31 as his very first soldering job. So it's very simple if you just take your time and use low heat and go slow and don't use any pressure, and you can solder to these things, and it's pretty simple. We'll show you. So I've covered this in my other videos on how I like to use some jumper wires that are cut off and simply tinned. The reason I do that, they're very flexible. Once you solder them on there, it'd be hardly any pressure put on the pad itself, and you won't rip the pad off of the board. I've seen too many times different videos or pictures from people where they've ripped the pads off their boards, and then they ended up they ruined the device. So all I do is I'll cut some of these DuPont jumper wires, like a female to female one, or it could be a female to male. Cut it off, strip off a little piece, and tin, which I mean by tin is just put a little bit of solder on the end of it, and then if you'll tin the pads, so you'll put solder on the wire and then solder on the pads, and once you do that, all you have to do is just heat up the pads with the wire and they'll pull straight together. And it's a very simple process. On the S31, voltage will be the top one. There's RX and there's TX. You're going to skip these two pads, and the very bottom one is ground. And we'll leave an additional picture of these pinouts in the description of the video. So if you don't have any, they call helping hands, I highly recommend them. There's several different types out here. Someone else recommended me this purple one with this aluminum plate, and it has like 5 or 6 different plastic arms, and they all have alligator clips on them. I usually use maybe 2 or 3 of the clips, but it's really helped me out. The solder I'm using is 0.015 diameter, and I'll leave a link in the description of the solder. I find the very fine solder, you do have to use a bit of it, but you're less likely to make a mess, and it's much easier to do your soldering with a smaller wire. There's one. You'll notice I'm not using any solder right now because we have enough from tinning. There's 2. Next, what we'll do is we're going to connect these up to the USB FTDI adapter. So to connect the device, brown is our voltage, VCC. We won't want to get these backwards. Potentially it could cause the device not to work or ruin it. The gray is our ground. Orange is TX, so orange goes to RX. If we do have these backwards for RX and TX, we can simply swap them around. You'll want to hold the button on the front without touching anything, really. Hold it down and then plug it in, and then you can let go of the button. So we need to go to the Tasmota GitHub page. We'll leave the link in the description. Go to releases. As of the recording of this video, the latest release is 6.3.0. We'll scroll down to sonoff.bin and we'll download that. Once that's downloaded, easiest flashing tool that we've found is if you go to the ESP Easy GitHub page, which we'll leave a link as well. Go to their releases and download ESP Easy Mega. Once that's downloaded, you'll need to extract the zip and put the sonoff.bin you downloaded in the same folder. So you'll double click Flash ESP8266. Pick the COM port you'll need. Mine happens to be COM27. Firmware will be your sonoff.bin, and hit flash. You'll know it's working when you get all the dots and showing writing flash. If it's not working, you need to switch the RX and TX wires and hold down GPIO 0, which is the button, cycle the power while holding the button, and try it again. It may take you a few times. If not, you may check your wires, make sure that you haven't soldered correctly, and try again. So once you've flashed it, I would power cycle the unit by removing the USB power from the computer and plugging it back in. Pull up Termite, made by CompuPhase. If you don't already have it, you can go download it from CompuPhase. Go to Settings, change the COM port to what you need for your device. Mine's COM27, you'll want 115.200.81NN. Leave everything else at default. Once you connect, click down here at the bottom, hit enter, and you should see something similar to this. If you see this result, you know that you are talking to the S31 through Tasmota. At that point, you can enter in your SSID and password if you like, and you're using a backlog. Take a quick second and we'll explain the various pieces of the backlog, which just is a combination of commands piled all together. So we're setting the SSID, the password, the MQTT host, MQTT user, MQTT password. We're going to set the power retain to 1. We're setting the topic to Sonoff washer. We're going to set the sensor retain to 1, and this will allow the wattages to stay in Home Assistant. The power on state is to be set to 1 as well. Power on state Since this is a washer, we always want the power to be on and never to be, if it reboots during a power loss, we wouldn't want the relay to be in the off state for some reason. And then we're setting the friendly name to Sonoff washer, same as the topic, keep it simple. Of course, you'll take this information, change it to your Wi-Fi, SSID, password, and other information, and we'll paste that into the termite. So once the unit boots up, after you have it on your Wi-Fi, we'll go to configuration, configure module. You need to change it to the 41 Sonoff S31. Don't change the GPIO pins, just hit save, let it reboot. Once it comes up, you'll see the voltage, current, power, etc. Of course, we're not seeing any voltage because we do not have it hooked to mains power yet. So let's unsolder these wires. It's really simple. We put it back in the helping hands. We slowly put pressure on the wire by pulling on it and just tap the solder where it melts and pull it off. And if you end up with a big glob of solder, clean your solder tip, remelt it, and then pull it off. And you'll have a little bit on there, but that's fine. It's going to stay inside the case. And we'll pull off the other ones. One thing you want to do before you finish unsoldering is inspect the pads and make sure that you can see space, green board, and not solder between all of your pads. You don't want it connecting to anything, and make sure that ground does not have any solder connecting to this capacitor right here. We'll reverse the process. Take the case. It doesn't require any force. Simply slide it in. It should drop right in. Then we'll take our 3 screws, and I like to do is get all 3 of them started before we tighten any of them up. That way you know everything lines up. Okay, got the screws in. Once you line up all the prongs, snap it on. That's it. Let's connect it to mains power and pull up the web interface and see if it works. Once we've connected it to mains power, we'll pull up the web interface using the same IP address, or you may have to go to your router and find that IP address again. Click the toggle. We'll hear the relay click on. A few seconds later, you should see the voltage come up. Next thing we need to do, a calibration of the voltage and the current. If you have a voltmeter or some sort of other meter that will detect the voltage, if you plug that into the same circuit, you can use that to set your voltage. For your current, if you know a known source, such as a light bulb or some other higher wattage device, go obtain that and we'll plug it into here and we'll set that as the current. One example would be a 60-watt light bulb. You could do an LED bulb, but it might not be as good as a calibration due to the smaller wattage used by those. So I would recommend a higher wattage device that you know the wattage of, such as an old incandescent 100-watt bulb or 60-watt bulb. Next up is the calibration. So I had the device connect. I'm using a kilowatt meter. To calibrate it, we're going to look on the Tasmodo wiki. There's the Sonoff PAL and PAL R2 section, which also applies to the S31. We're going to set the voltage first. In the console, if you do voltage set, and we're at 121.0. So now once we've set the voltage, you can see the voltage on this GUI is the same as the meter. So let's put a load on it. So we'll change the meter over to wattage. We've got 1.4 watts registering. We'll turn the unit on, and you can already see we're running a little high. We're showing 50 watts versus 42, 49. I think we're 8 or 9 watts above what the meter is showing. So to fix that, we go to console. So we'll do it again. Power set 64. See if we got there. 62, 61, which is pretty close. So we should be good enough. So once you got this reading in your wattage and your voltage, the calibration's done. Let's move on to Home Assistant and put in the sensors. So if you open up your configuration.yaml, or if you have it split and you have it into a sensor YAML, you'll need to put it in there. Wherever you store your sensors section, we need to copy and paste in some things. The first one we're going to copy in, which I'll explain in one of the automations what I use this for, is it's going to be a simple sensor that points to a custom topic. We're going to pull in one of these so we can explain it. So the platform is MQTT. We're going to name it washer watts. The state topic is telemetry Sonoff washer sensor. And where I get that from, if you look in the console, you will see these telemetry Sonoff washer sensor topics being posted. Or if you've changed the name will be different right here. Simply copy this section out and we'll put that in the configuration YAML. Next, the value template. We're going to pull out the energy section with power. And you can see that right here in the sensor that it's getting energy. And this starts the section of energy. And you could pull these start times, the totals. You can pull anything out of here if you want. And we're pulling the power out. The unit of measurement, we're doing watts. The icon, I set like a little flash circle. It shows a little lightning bolt with a circle. The availability topic is very similar to the sensor. That's the telemetry Sonoff washer last will and testament. And what that will do is that will show when the unit is off, like the Sonoff is falling off the network or there's an issue with it or someone's unplugged it, it'll show unavailable. So it's really simple. You can copy and paste several of these and you can grab any of the information out of here, the voltage, the current, the apparent power, reactive power. I don't have those in mine, or the power factors. You can pull all those out and show those and expose them to Home Assistant if you like. So we're going to copy the other ones in. One additional one I wanted to show you is you can do this on any of the Tasmota devices. Look at the state topic. We're using telemetry, Sonoff washer, but we're using the state section. And if we go back and look in the console, we'll find a state sensor. And again, you can use the same thing you've learned. You can pull out any of these sections. If you want to see the voltage, you could expose that to Home Assistant. But keep in mind, the telemetry only posts every so often. So what I'm pulling is the RSSI for in the ESP world. It's a 0 to 100 scale based on the Wi-Fi signal. And we'll create a easy sensor to see the Wi-Fi signal of the Sonoff device. And I'll include all of these configurations in the description of the video. Save your YAML configurations. Go to General, check Config, Configuration Valid, and click Restart. Once Home Assistant restarts, and yours may say unknown for the washer state because I've used it before, and so mine shows the idle. You should see your voltage, your watts, your amps, energy used, and the washer signal will populate once one of those state messages come across. So let's turn on the unit and see if we should get wattage showing on our card. And we can see we have our watts and our amps showing, and also we're showing now our washer signal. So it's that simple to get information in from the S31 into Home Assistant. And also once it runs for a little while, you will be able to see your graphs and the amps and everything else in your system. So if you look in your automations YAML, is the name of the automation is washer state and starts. Platform is numeric state. It's watching the sensor washer watts, which is the wattage of the washing machine. And this may vary based on your washing machine. You'll need to run it through a cycle and take note of the different wattages it pulls based on the different events. Well, my particular unit, whenever we turn it on and it starts to fill, it pulls about 6 to 7 watts. So what I'd have is I say, if it's above 5 watts for 4 seconds, then consider the washer as running. So the action is I actually do a MQTT publish to that has state washer, and the payload is washing. And that's why I can easily see on my card the state, whether it's washing or idle. I have another automation, washer state idle. Pretty simple. Again, this may vary for your machine. If it's below 5 watts, for 5 minutes. And I found, and I had to extend this a couple times. I had it for 3 minutes, then I had it for 4, and I put it to 5. One of our particular loads, if we put it on large, bulky loads, it'll do a soak for like 3 to 4 minutes, and it was causing the washing machine to notify us that it was finished when it wasn't. So the action is, just like the other one, it does an MQTT publish, the same has state washer of the payload of idle with retain of true. The third automation I have, it's called washer finished. It watches that sensor that points to the MQTT topic, and it's watching it to see when it goes from washing to idle. Now, one other condition I have, and not all of you may be able to do this based on your dryer, is I don't want it notifying us to move the clothes over when the dryer's still going, because we couldn't put the clothes in the dryer. It hits all of our Google Home speakers, and it sets the volume, and it performs a TTS, Google Say, and send over the laundry and the washer can be moved over.
Laundry and the washer can be moved over.
So we'll hear that on all of our speakers, and we know we can move the laundry over. And it's been great. The laundry gets done so much faster because the kids will hear the notifications and go change the laundry over. And the same type thing happens when it sees the dryer go from drying to idle. It hits our speakers and sends this message.
Hey, guess what? The dryer is done. Exciting stuff, right?
Again, eventually I will make it rotate several different messages to annoy the kids.
Hey, guess what? The dryer is done. Exciting stuff, right?
And that's it. It's super simple. Monitor your wattage and your voltage from your washing machine and possibly your dryer or other components in your house that you could automate, such as your dishwasher. You can do all your actionable notifications. You can push it to text messages or emails, push bullet, or whatever you want to use for your notification platform. Thanks for watching. Be sure and subscribe if you haven't already. Hit the bell icon so you can see our next video. Thumbs up, and let us know in the comments of what you'd like to see next. We're always looking for ideas and different little projects to show that benefits everybody.
Take care and see you in the next automation.